When a washer machine stops working, checking the voltage and the wires is a good first step. Readings of 120 volts on the black wire, 13 volts in the white wire, 120 volts from black to ground, and 60 volts from black to white suggest several possible causes. One potential issue is a loose or damaged neutral connection. If the neutral wire isn't securely connected or is damaged, it can result in a reduced voltage on the neutral wire, leading to the unusual readings observed. Another possibility is a tripped ground fault circuit interrupter, or GFCI. A GFCI is a safety device that trips when it detects a difference in current between the hot and neutral wires. If a GFCI has tripped, it may be preventing the washing machine from receiving the proper voltage. Multiple ground paths in the circuit could also be affecting the voltage readings in the neutral wire. If there are multiple ground paths, such as through a metal conduit or a grounding rod, this can influence the voltage readings. To troubleshoot these issues, consider these steps. Firstly, check the neutral wire connection. Inspect the neutral wire and its connection points carefully. Ensure it is securely connected to both the washer machine and the electrical panel. A loose connection can cause significant voltage drops. Secondly, reset the GFCI. If the washing machine is connected to a GFCI outlet, locate the GFCI and press the reset button. If the outlet continues to trip, there may be a ground fault issue somewhere in the circuit that needs further investigation. Thirdly, test the grounding system. Use a multimeter to test the grounding system's integrity. Check the resistance between the ground wire and a known ground, such as a metal water pipe. A high resistance indicates that the grounding system may not be functioning properly. If you're unable to resolve the issue yourself, it's recommended to contact a qualified electrician to diagnose and repair the problem. They can ensure that the wiring and grounding are safe and that the washing machine is receiving the proper voltage. When checking the neutral wire connection, pay close attention to the wire nuts or terminal screws. Make sure they're tight and that the wires are making solid contact. Look for any signs of corrosion or damage to the wires themselves. If you find any issues, clean or replace the affected components. Resetting the GFCI is a simple process, but if it trips repeatedly, it indicates a more serious problem. Do not simply bypass the GFCI, as this could create a safety hazard. Instead, investigate the cause of the tripping. Testing the grounding system involves using a multimeter to measure the resistance between the ground wire and a known good ground. A low resistance, ideally close to 0 ohms, indicates a good ground connection. A high resistance suggests a problem with the grounding system, such as a loose connection or a corroded ground rod. When using a multimeter, ensure it is set to the correct range for measuring resistance. Also, be careful not to touch the metal probes while taking the measurement, as this can affect the reading. If you suspect a problem with the grounding system, you may need to inspect the ground rod and its connection to the grounding wire. Make sure the ground rod is driven deep enough into the ground and that the connection is secure and free from corrosion. In some cases, it may be necessary to replace the ground rod or the grounding wire. It's important to understand the basics of electrical circuits to effectively troubleshoot voltage problems. A typical residential circuit consists of a hot wire, a neutral wire, and a ground wire. The hot wire carries the electrical current from the power source to the appliance, while the neutral wire returns the current back to the power source. The ground wire provides a safety path for the current to flow in the event of a fault, such as a short circuit. The voltage between the hot wire and the neutral wire should be approximately 120 volts in a standard residential circuit. The voltage between the hot wire and the ground wire should also be approximately 120 volts. The voltage between the neutral wire and the ground wire should be close to 0 volts. If the voltage readings deviate significantly from these values, it indicates a problem with the circuit. For example, a low voltage on the hot wire could indicate a loose connection or an overloaded circuit. A high voltage on the neutral wire could indicate a problem with the grounding system. When troubleshooting electrical problems, always prioritize safety. Turn off the power to the circuit before working on any wiring. Use insulated tools and wear safety glasses. If you are not comfortable working with electricity, it's best to call a qualified electrician. Electricians have the training and experience to safely diagnose and repair electrical problems. They also have access to specialized equipment such as circuit tracers and insulation testers. In addition to checking the voltage, it's also important to inspect the wiring for any signs of damage, such as frayed insulation or loose connections. Damaged wiring can create a fire hazard and should be repaired or replaced immediately. When making electrical repairs, always use the correct type and size of wire. Refer to the National Electrical Code, or NEC, for guidance on wiring practices. The NEC is a set of standards for the safe installation of electrical wiring and equipment. It is important to follow the NEC to ensure that electrical installations are safe and compliant with local regulations. In addition to the NEC, there may be local electrical codes that must be followed. Check with your local building department to determine the specific electrical codes that apply in your area. When replacing electrical components such as outlets or switches, use high-quality products that are listed by a recognized testing laboratory, such as Underwriters Laboratories or UL. UL listing indicates that the product has been tested and meets safety standards. Before starting any electrical work, obtain the necessary permits from your local building department. Permits are required for most electrical work to ensure that it is done safely and in compliance with local codes. When working on electrical circuits, it's helpful to have a basic understanding of electrical theory. This includes concepts such as voltage, current, resistance, and power. Voltage is the electrical potential difference between 2 points in a circuit. It is measured in volts. Current is the flow of electrical charge through a circuit. It is measured in amps. Resistance is the opposition to the flow of current in a circuit. It is measured in ohms. Power is the rate at which electrical energy is transferred in a circuit. It is measured in watts. The relationship between voltage, current, and resistance is described by Ohm's law, which states that voltage equals current times resistance, or volts equals amps times ohms. This formula can be used to calculate the voltage, current, or resistance in a circuit if the other two values are known. Another important concept in electrical theory is grounding. Grounding is the process of connecting a circuit to the earth, which provides a reference point for voltage. Grounding helps to protect against electrical shock and prevent damage to equipment. There are two main types of grounding: system grounding and equipment grounding. System grounding is the grounding of the electrical system itself, typically at the service entrance. Equipment grounding is the grounding of the metal parts of electrical equipment, such as appliances and enclosures. Both system grounding and equipment grounding are important for electrical safety. When troubleshooting electrical problems, it's important to have the right tools. Some essential tools for electrical work include a multimeter, a wire stripper, a screwdriver, a pair of pliers, and a voltage tester. A multimeter is a versatile tool that can be used to measure voltage, current, and resistance. A wire stripper is used to remove the insulation from electrical wires without damaging the conductor. A screwdriver is used to tighten and loosen screws. A pair of pliers is used to grip and bend wires. A voltage tester is used to check for the presence of voltage in a circuit. When using electrical tools, always follow the manufacturer's instructions and wear safety glasses. Be sure to keep your tools in good condition and replace them when they become worn or damaged. Remember that electrical work can be dangerous if not done properly. If you are not comfortable working with electricity, it's best to call a qualified electrician. By following these tips, you can safely and effectively troubleshoot voltage problems in your washing machine and other electrical equipment. A reading of 13 volts on the neutral wire is abnormal and usually indicates a problem with the neutral connection. The neutral wire should be close to 0 volts. The 60-volt reading between the hot and neutral wires is also abnormal and suggests that the neutral wire is not providing a proper return path for the current. This can cause appliances to malfunction or not work at all. When troubleshooting electrical circuits, it is important to be systematic and methodical. Start by checking the simplest things first, such as the circuit breaker or fuse. Then check the wiring for any signs of damage or loose connections. If you are unable to find the problem, it may be necessary to call a qualified electrician. Also, consider the age of the wiring in the house. Older wiring may be more prone to problems such as insulation breakdown and corrosion. If the wiring is old or damaged, it may need to be replaced. Replacing the wiring can be a significant expense, but it can also improve the safety and reliability of the electrical system. When replacing wiring, use the correct type and size of wire. Consult the NEC or a qualified electrician for guidance on selecting the appropriate wire. In addition to the wiring itself, it's also important to check the electrical panel for any signs of problems. Look for loose connections, corrosion, or damage to the circuit breakers or fuses. If you find any problems, have the panel inspected and repaired by a qualified electrician. Electrical panels can be dangerous to work on, so it's best to leave this task to the professionals. It is also wise to consider environmental factors that might contribute to electrical problems. Moisture, for example, can cause corrosion and insulation breakdown. If the electrical system is exposed to moisture, take steps to protect it. This may involve sealing any openings in the walls or roof, or installing a dehumidifier in the area. Pests can also damage electrical wiring. Rodents and insects can chew on the insulation, creating a fire hazard. If you suspect that pests are damaging the wiring, take steps to eliminate them and repair any damage. Keeping the area around the electrical panel clean and free of clutter can also help to prevent problems. Do not store flammable materials near the electrical panel, as this could create a fire hazard. Ensure that the electrical panel is easily accessible in case of an emergency. Consider that electrical codes and regulations are constantly evolving. Stay up to date on the latest codes and regulations to ensure that your electrical system is safe and compliant. You can find information on electrical codes and regulations from your local building department or from the NEC. Remember that electrical safety is everyone's responsibility. By following these tips, you can help to prevent electrical accidents and ensure that your electrical system is safe and reliable. When dealing with electrical issues, always err on the side of caution. If you are unsure about something, it's best to consult with a qualified electrician. Trying to fix electrical problems yourself without the proper knowledge and experience can be dangerous. The combination of 13 volts in the neutral and 60 volts between hot and neutral strongly suggests a high resistance connection in the neutral path. This could be at the outlet itself, in a junction box upstream, or even at the main electrical panel. The 120 volts reading from black to ground indicates that the hot wire is properly energized. The low voltage on the neutral is causing the appliance to not function correctly. Finding and correcting this high resistance neutral connection is critical for restoring power and preventing potential hazards. It may be beneficial to turn off the breaker and systematically check each connection in the circuit, starting with the easiest to access.